We can argue about the status of objects in our solar system all day. We can talk about whether or not Pluto is a planet. To be honest, any planet in any solar system has received the short end of the stick. But did you know not all planets orbit a star? That's true. They are rogue planets that aren't connected to any star or system and are drifting alone through the galaxy. So, how does this happen? How are the rogue planets formed? Something that happened in the way they were born? Watch till the end to find out what happened to them during their birth.
Audio Jungle.
All of the planets orbit their parent star, which is neatly arranged in ellipses and rings. Even the asteroid belt has dry and icy boundary lines. Planets do what they're told. They orbit that star until the end of time. However, not all of them are the same. Imagine an orphan planet wandering through space, far from its home solar system. It is estimated that there are billions of rogue planets in the Milky Way. A rogue planet is any planet that does not orbit a star. Instead of being part of a solar system, it orbits the Milky Way on its own. These planets are extremely hard to spot. They're really small and only emit a weak infrared glow from any internal heat they may have. In astronomy, small and dim are a difficult combination to overcome, so all known rogue planets are almost entirely candidates and subject to debate. Counting exoplanets is a difficult task even when they are in a planetary system. As we know, there are two primary methods for detecting a planet's orbit around a star. The radical velocity method and the transit method are two of them. Both of these methods rely on the presence of a star, making them useless when it comes to rogue planets. Nonetheless, there are some methods for detecting these wanderers. Two rogue planets were discovered in 2018 due to the way their gravity bends light from behind them. Infrared imaging has revealed others. In total, around 70 to 170 rogue planets, or candidate rogue planets, have been identified, compared to 3,917 exoplanets in planetary systems. That is a large gap. To determine how many rogue planets might be out there, drifting darkly through the galaxy, astronomers at the University of Leiden in the Netherlands ran sophisticated mathematical simulations of the Orion trapezium, a cluster of young stars in the heart of the Orion Nebula. But you're probably wondering how a planet goes rogue. Is it just going to go off on its own one day? No, of course not. Some scientists believe that rogue planets can form from the collapse of a gas cloud that is too small to result in the formation of a star, or that they were kicked out of their parent system. However, the exact reason is likely unknown. They are not only lonely, but also different. The conditions of these celestial objects are still largely unknown. However, experts agree that they are very different from Earth, or any other planet with a normal orbit. Rogue planets do not have daylight because they do not orbit a star. Instead, they exist in perpetual darkness, meaning they have little warmth and are icy worlds. What's truly amazing about rogue planets is that they could be home to life. You heard it right. The temperate conditions that allow liquid water to exist may last for billions of years, even if the planet is floating through space rather than orbiting a star. When planets form around a young star, they collect a primordial atmosphere primarily composed of hydrogen and helium. Many planets eventually lose their atmospheres as heavier gases like oxygen and nitrogen replace them, just as the rocky worlds in our solar system did. However, some planets larger than Earth may be able to retain their primordial air. This is significant because at high enough pressures, hydrogen can act like a greenhouse gas, absorbing heat and trapping it within the atmosphere rather than allowing it to radiate away to space. Christoph Mortacini of the University of Bern in Switzerland and his colleagues investigated how long this effect could keep worlds slightly larger than Earth in the right temperature range for liquid water. They discovered that, depending on the planet's mass and distance from its star, the hydrogen greenhouse effect could keep planets warm for up to 8 billion years. This was true even on so-called rogue planets with no star, because thick atmospheres are expected to trap heat from radioactive element decay underground. We don't know whether the presence of water will result in the emergence of life, but it appears possible that life could exist for a very long time, Mortacini says. Some bacteria on Earth can survive in similar conditions, surrounded by hydrogen and helium rather than nitrogen and oxygen. Because these atmospheres would be so thick, with masses 100 times greater than Earth's, the pressure on the surfaces of these worlds would be high, with few temperature variations. Day and night provide all of these temperature differences on Earth, but these planets do not. The view would be foggy, the temperature would be consistent, and life would be a little slower. So, what would life be like on such a planet? You can certainly imagine something larger than microbes, one of the researchers says, even if it isn't as complicated as the most complex things we see here. We might not see dolphins or other developed species. We may never really know if intelligent life can thrive on these planets. However, the possibility may also indicate a hidden abundance and diversity of organisms throughout the universe. Even on Earth, we've been amazed by extremophiles' ability to survive in the most hostile environments. Why not on a rogue planet in the dark cold of interstellar space? But it certainly sparks the imagination. What do you guys think? Don't forget to tell us in the comments.